All right, here we go. Lesson 2. We just got done talking about why the marginal revenue is less than demand, and it has to do with the law of demand, the idea that to sell more of an item we have to lower our price, even for a monopoly. That is the case. So, marginal revenue is less than demand. Monopoly gang sign, right? When you get question, we got a graph of monopoly, we know we need to put that in there. Okay, so how do we calculate our marginal revenue? It's actually pretty easy. Just like we did on the last table, we're going to take our total revenue, and then it's going to be the change in our total revenue, right? Marginal, additional revenue. Total revenue, additional revenue. So let's just take a quick look at this particular problem here. $6 times 0 quantity demanded is going to give us a total revenue of 0. $5 times 1 is going to give us 5. $4 times 2, 8. 3 is 9, and you can go on down through there, and that's going to be our total revenue as we lower our price. Right? As we lower our price, we get our total revenue. All right. Then we'll take a look at our marginal revenue. We went from 0 total revenue to $5. So our marginal revenue was 5. We went from 5 to 8. Marginal revenue, excuse me, marginal revenue is 3. 8 to 9 is 1, and then it actually ends up going negative, and we'll talk about that here in a little bit. So if we were to draw the demand and the marginal revenue curves right now, we would get our monopoly gang side. Okay, marginal revenue does not equal the price. Okay, so if we plotted the demand, the marginal revenue, and the total revenue curves on these particular graphs right here, this is what it would end up looking like. Okay, so for 1 unit, we could sell it for $5. I'm sorry, for $15. So our demand or our price would be $15. Our marginal revenue would be $15. That's just for the first unit, right? In order for us to make more revenue, then we are going to have to lower our price, and as we do, our marginal revenue tends to drop at a greater rate. Okay, so what happens, notice this question here, what happens when the total revenue, or what happens to total revenue when marginal revenue equals 0? Well, think about this. If you're selling an item, every time you sell an item, if you're getting a positive marginal revenue, you got a cash register sitting there. If I'm getting part of a positive marginal revenue, I'm putting more and more money into my cash register. So my total revenue should be going up. At the point it hits 0, that's the most money I'm going to make. If I sell this next item for a negative, that means I got to take money out of the cash register and hand back to somebody. That doesn't make really good sense. Now, for monopolies, and we'll talk about that in a few minutes. But so anyway, so what happens to total revenue when marginal revenue hits 0 is the total revenue is at its max. Okay, if we just compared these graphs right here where I got the little highlight going over, you'll see that that's the case. Now, total revenue is increasing as long as marginal revenue is positive, right? We're putting money in the cash register. All right, cash register is getting more and more and more full. We get to this point right here, cash register is full, and if we want to go any further than that, we're going to start handing money back to people, which doesn't make a lot of sense. Your spidey sense should be kicking in right now, and you should kind of know what's up. All right. So, yeah, this is just a graphic analysis of what I just talked about. Total revenue is at its peak when marginal revenue hits 0. All right, let's talk about the elastic and inelastic range. All right, and if you go way back to Unit 2, and we talked about elasticity, it said that, and we used a total revenue test, right, to determine something's elasticity. We knew that the range in which total revenue is going up, right, price is going down, total revenue is going up, so we're lowering the price and people are buying more, then we know that that particular part of the demand, the curve is elastic. Okay, total revenue test. If price falls and total revenue increases, then the demand is elastic, right? If we get the opposite, then we know that the demand is inelastic. Okay, that's going to happen, and it's pretty easy in a monopoly. That's going to happen when marginal revenue hits zero. All right, so there's a lot going on there. When marginal revenue hits zero, we know that total revenue is at its max. We also know that a monopoly at that point is operating in the inelastic range. Now, I'll give you something in a few minutes that's going to help you out a little bit further. A monopoly will only produce in the elastic range. Well, that would make sense, right? They're not going to take money out of the cash register and hand back to customers to buy something. So they're going to only produce in the elastic range. All right? So let's talk about maximizing profit. MR equals MC. All right, this is what our monopoly graph is now going to look like. Things look a little bit more confusing than they did before, but trust me, they aren't. This is now, these used to be together. Remember, this is Mr. Dart in perfect competition. Well, these things are still here. They're just not together anymore because the law of demand, monopoly gang sign, says that marginal revenue and demand or price is not the same. So what output should this monopoly produce? You're right, they should produce where MR equals MC. So they should produce 6 units, and they should charge, that's where it gets a little bit tricky. Watch what happens here. So in class we would do this. I would ask you to calculate the total revenue, the total cost, and if there's a profit or loss according to this graph right here. All right. Key point when working with a graph on a monopoly. All right. A week ago this time, we would have said we're going to produce 6 units because that's where MR equals MC, and our total revenue would be, but it's not, because price and marginal revenue for monopoly is not the same. So what is our total revenue going to be now? Well, we're still going to produce 6 units because that's where marginal revenue equals marginal cost, but we're going to charge up to the demand. We're going to charge what consumers are willing to pay for our item. All right, and so that's going to look like this. Now we can look at our total revenue. We would produce 6 units and we would charge $7. All right, so now our total revenue would be, I heard it in the back, $42. All right, so we can also now see our profit. All right, so if we go here up to our cost curve, our average total cost, just like we did before, we would know that our total cost, our average total cost per unit is $6, and our price would be $7. A couple different ways we can calculate profit, right? We can do 42 minus 36, 42 being the total revenue minus 36 total cost, or we can say we're making $1 each times 6 units. Okay, so either way we calculate that we're getting a profit of $6 here on this curve. All right, so here's a conclusion. The monopolist produces where MR equals MC, just like always, but they're going to charge the price the consumers are willing to pay. So the price will not be here, because we know from our demand curves what we've already learned, that the consumer is willing to pay this price right here. All right, let's go back here. Let's go one more time. All right, where are we going to produce? We're going to produce where MR equals MC. We're going to charge up to the demand curve, which is $7. That gives us $42 in total revenue. Our total cost, there's our total revenue. Our total cost is right here at the cost curve. Once we've got our quantity, we just continue to go straight. It gives us all our answers right there. Right? We know that's our price, we know that's our cost, and we know that's the quantity we're going to produce right there. Okay? And hopefully we can look at this now and go, okay, yeah, I see the profit. I see that my average total cost curve is below my price. All right? That's something from last unit, and we're making $1 each. Profit is $6. Okay? What if the costs are higher? Ooh, notice where our average total cost curve is here now. What if our cost is higher? So what is the total revenue here? Total revenue, we're going to produce where MR equals MC. we're going to charge up to $9 for a total revenue of $90. Well, what's our cost? Well, our cost is $10 a unit. All right, so let's see what that looks like. Okay, our cost is $1 higher per unit. So if we're selling 10 units, that means we're going to, that's right, I heard it in the back, we're going to lose $10. Right? Total revenue is 90, total cost is 100. That is a loss of $10. All right, if we were in class right now, I would ask you to go into prediction mode and tell me if this monopoly would shut down. Well, we know shutdown rule is the same, right? Price would have to be what? Below AVC, right? So they would not shut down. And we'll talk more about this. All right, this is some practice here for you to identify and calculate total revenue. So let's just go through this one real quick. We would produce where MR equals MC. So we're going to produce 5 units, and we're going to charge $10. So our total revenue would be $50. Our total cost, we're going to produce 5. Our total cost is now here, which is $5 times 5 units. So our total cost would be $25. That's located right there. All right, and then we get our profit or loss. We get a profit of $25. Or if asked, we could also figure out profit or loss per unit, because we know that we are making from 5 up to 10, we're making $5 per unit. All right, everybody good? Excellent. Identify and calculate here. Total revenue, total cost, profit or loss per unit. Let's roll through it. We're going to produce where MR equals MC, so we're going to produce 6 units. We're going to charge up to the demand curve, which is $9. Right, so our total revenue in this situation is $54. Our total cost, marginal cost equals ATC, so that must be our ATC curve. That's kind of weird looking, which we know AP will do to us, and this is why we do it this way. So we're going, if it's labeled ATC, then that's our ATC. Even though you and I know an ATC curve doesn't look like that, so our total cost is going to be $36. We can do the math, or we can do the profit per unit and calculate, but that is our profit of $18, or 9 minus 6, $3 per unit. And we can see that there. Quick practice question from the 2012 AP exam. If the firm produces 10 units of output, which it would, its economic profits would equal, let me show you something real quick. If we would produce here, we know that this is our cost and this is our price. All right? So we know that we're making $5 every time we sell one, and we are selling 10 of those. So your answer should be B. All right? If you got B, give yourself a high five. Here's another one. Which of the following is most likely to occur if the firm increases production beyond 10 units? If it goes beyond 10 units, I challenge you to stop the video and take a look. I'll give you a hint. If we were to sell more than 10 units, we must lower the price. Yeah. So the firm will have to lower its price to sell more than 10 units. All right, and that's just a law of demand. Okay. All right, I'm at 14 minutes. I'm gonna kind of wrap up right there. I'll come back in a little bit with are monopolies efficient? We know from our true-false quiz that monopolies are not necessarily efficient, and I will show you why. So anyway, there we go. There you have it. Practice it, and talk to you soon.